Okay, today we're going to talk about the mole. And you guys have heard me use the word a mole before, but I've never really defined it. But in chemistry, you use the mole to measure the amount of something. And it can be measured in different ways by counting. You guys know how to count atoms. By mass, when you use the balance, and by volume, which we'll talk about a little bit more when we get to gas laws. The mole is a unit in chemistry, and it's used in conversions. And we just started to talk about conversion factors before we closed. So a mole of any substance contains Avogadro's number. That's a huge number. It's 6.02 followed by times 10 to the 23rd. So 6.02 followed by 21 zeros. So when you're converting from a mole to Avogadro's number, they call it representative particles, because Avogadro's number can represent a mole of atoms, like 1 mole of sodium is equal to 6.02 times 10 to the 23rd atoms. It can be a molecule, like 1 mole of O2. Remember, O2 is one of those diatomic molecules that doesn't like to be by itself, is still equal to 6.02 times 10 to the 23rd molecules. Or 1 mole of water, it's still 6.02 times 10 to the 23rd molecules. A mole of anything is 6.02 times 10 to the 23rd. A representative particle, and the reason they say representative particles is because it can be an atom, a molecule, an ion. It doesn't matter. All that matters is they all equal 6.02 times 10 to the 23rd. So when you convert between moles and representative particles, again, they can be atoms, ions, or molecules. The equation is 1 mole is equal to 6.02 times 10 to the 23rd representative particles. It gives you 2 conversion factors. The first one is 1 mole over 6.02 times 10 to the 23rd, or it can be 6.02 times 10 to the 23rd particles over a mole. And you decide that by which one you want to get rid of. This is a mole map, and today the only part of the mole map we're going to talk about is converting between mole and representative particles. So we're talking about this branch of the map right here. Now, that gives you 2 possible conversion factors. And we just talked about those. Either Avogadro's number is on the top, over 1 mole, or 1 mole is over Avogadro's number. So the way this is done is you convert, we're going to do an example. So you're going to convert 2 moles of carbon dioxide, CO2, to molecules. You start by writing down what is given. You always start there. Then you decide which conversion factor you will use. The conversion factor you're going to use is going to be the one that puts the unit that you're given on the bottom. So you have those 2 conversion factors, 1 mole over 6.02 times 10 to the 23rd, or 6.02 times 10 to the 23rd over 1 mole. In this case, you're given 2 moles of CO2. The unit that you want to cancel goes on the bottom. So in this case, you're going to write down what you're given, 2 moles of CO2, you put it over 1. This stands for times or multiplied by. Remember, I want to get rid of the unit mole, so I put 1 mole of CO2 on the bottom, and on the top I put Avogadro's number, 6.02 times 10 to the 23rd. When I do that, it means I end up multiplying 2 times Avogadro's number, and technically it's divided by 1, but you really don't have to worry about that. When you do that, you end up with 1.2 times 10 to the 24th molecules of carbon dioxide. But before we go on any further and do another example, let's talk about how you enter that into a calculator. When you enter 6.02 times 10 to the 23rd into a calculator, you enter 6.02, you hit the double E button, and then your exponent, 23. You do not enter times 10, but you must write it in your answer. Don't forget. If we're going the other way, this time we're going to convert 2.1 times 10 to the 24th atoms of magnesium. Remember, it can be atoms or molecules. It doesn't matter. And we're going to convert those atoms to moles. First, you write what you're given. You use the conversion factor that puts the unit that you're given and you want to change on the bottom, and then you solve the problem. So in this case, we were given 2.1 times 10 to the 24th atoms of magnesium. So in this case, I'm going to put Avogadro's number on the bottom. 6.02 times 10 to the 23rd atoms of magnesium is equal to 1 mole of magnesium. So this would cross off my atoms. I would get rid of atoms. I would be left with moles. That's the unit I want in my answer. So in this case, technically it's 2.1 times 10 to the 24th times 1 divided by 6.02. Now remember, this can be over 1. I often don't put that 1 there, but it can be there, and there's nothing wrong with putting it there. So in this case, it would be 2.1 divided by Avogadro's number, 6.02. So into your calculator, you would enter 2.1 EE24. Then you would hit divided by 6.02 EE23. And the answer would end up being 3.4, like 88 something, round to 3.49. Do not forget units. These become really important. So 3.49 moles of magnesium.